Alright, so today we're going to take a look at section 2.4, which is on solving linear inequalities. So you're not going to be looking at inequalities that have any exponents of like 2 or 3. It's going to be simple linear inequalities. So what makes something an inequality? It has one of these 4 symbols in place of an equal sign. That's all. So it's got either a less than or equal to, greater than, or greater than or equal to. Right, so these are a couple examples of inequalities. The one on the left, it's just a true statement. The one on the right is a conditional inequality, and it could be true, or it could be false. Depends on the number you pick for x. So to figure out if a number is a solution, like let's say I wanted to know if 5 was a solution to the problem 3x is greater than 12. You take the number, you plug it in, and you see if you get a true statement. So to check if it's a solution, replace the variable with whatever number you're checking, and see if you get a true statement. So let's check 5 in this one. Isabel, if I plug in 5 for x, I get 3 times 5 gives me 15. And is 15 greater than 12? Mm-hmm. Yeah, so that means 5 is a solution. Is it the only solution? No, there's a bunch of solutions. Okay, that's what makes it different than an equation. Usually, linear equations have, well, I guess they could have one solution most of the time, or if it's an identity, it would have infinite solutions. But inequalities almost never have a single number as a solution. It's usually every number from this point greater, or it could be every number from a certain point smaller. It's usually one of those two. So if I wanted to check if 0 was a solution, 3 times 0 is 0. 0 is greater than 12? No. So 0 is a number that's not a solution. Questions on that idea? All right. So when we talk about inequalities, sometimes we have 2 inequalities going at the same time. And they're connected with a certain word. Does anybody know if you have a conjunction, what word the inequalities would be connected with? And, yeah, same thing in English. And is a conjunction. Well, same thing in math. Except when we write the word and between 2 mathematical sentences, a mathematical sentence for us looks like that. Okay? Obviously in English it looks a little different. But x is greater than -1 is a sentence. X is less than 3 is another sentence. We put the word and between them. And what we're basically saying now is you can pick any number between -1 and 3. That's usually what a conjunction kind of boils down to. It usually means between these 2 numbers. Now, one thing we can do with a conjunction, so we don't have to write it like this, we can combine x is greater than -1 and x is less than 3 into one thing. Okay, so I'll show you how it looks combined. There's 2 ways to combine it. This is one. You start with x in the middle. You put the smaller number on the left. You put the bigger number on the right. And you have both inequality symbols pointing to the smaller number. Okay. So if you look at it, x is less than 3. That part is right here. X is less than 3. And now the other part, it's a little hidden, but it's there. X is greater than -1. X is greater than -1. The thing is, when you combine it, you have to write one of the inequalities the other way. Okay, that's just how it always ends up working. We'll talk more about it, but if you look at what's in the blue box, it was pointing towards the -1 originally. It's still pointing at the -1 right now. Okay, so it's the same thing. The other way you can do it I usually do it this way, but if you want, you can put the x in the middle, put the bigger number on the left, smaller number on the right, and which way do you think my inequality symbols would point now? Bob, Nick? Well, they were pointing to the left the first time, so no, this is the other way. Yeah.
I didn't know if you meant the open way to the left or the...
Oh, which way? Yeah, I know what you mean. Yeah, it's a little confusing. Yeah, sorry about that. So yeah, this time they're going to be pointing to the right. So now you're saying x is greater than -1. That part's right there. And here's the other part. X is less than 3. Okay. Or 3 is greater than x. Means the same thing. Okay. So when you have a conjunction, think of the word and. It's there, but it's invisible. Okay. You don't see it anymore when you combine it all together. So what we're really looking at here is called an interval. Okay. The answer to that inequality is all numbers between -1 and 3. And this particular interval is called an open interval. So we're going to talk a little bit about the term open interval, closed interval, explain what that means. And then also what's called a bounded interval and an unbounded interval. So we're going to describe these 4 terms right now. So if you have an interval that is bounded, what bounded means is that the actual endpoints of your interval are numbers. -1 is the lower bound of my interval. 3 is the upper bound. -1 and 3 are numbers. Can anybody think of something that we use in an interval that's not a number? Yeah?
Infinity.
Infinity, yes. So if you throw an infinity in your interval, that's not bounded anymore. That's unbounded. So we'll talk about unbounded next. But bounded is when you start at a number, you stop at a number. No infinity symbol in the problem. And the 4 types of intervals that you can have that are bounded are a fully closed interval, which means bracket on each end. And what does a bracket mean compared to putting a parenthesis on it? Bracket means, yeah?
Equal to?
Right, bracket means you have the equal to. You can actually equal A and you can equal B. So you can have a fully closed interval, fully open interval, which is exactly what you have right here. You can't equal -1, you can't equal +3. So that's an open interval. Then you could also have half open. This one's half open on the right. And you could also have half open on the left. Technically, you could also say half closed, but I'm trying to be optimistic, so I'll use open rather than closed. So half open. And again, A and B are numbers. So A and B would not be infinity here. If you let one of your bounds be infinity, so you're saying you can go up as high as you want or you can go as low as you want, now you've created an unbounded interval. Okay, so these are all examples of unbounded intervals. The first one in the upper left is unbounded on the left, and it's bounded and closed on the right. The one below it is unbounded on the left, and it's bounded and open on the right. Okay. In the upper right, we got an interval that's unbounded on the other side. So it's unbounded on the right, but it's bounded and closed on the left. And the one below it, bounded and open on the left. And technically, you could also have this as an unbounded interval as well. could be unbounded on both ends. I don't know why I didn't write that one down, but that's also unbounded. Okay, so open and closed has to do with whether or not you can equal or not equal the number. Bounded or unbounded has to do with whether or not you have infinity in the interval. Okay. Any questions on those four terms? Bounded, unbounded, open, closed. Okay. All right, so what I want to do is I want to take that, which is an interval, and I want to write it as an inequality. Isaac, using those words, four words we just went over, how would you describe this interval? So I'm looking for just a single word. Well, I guess you could use two words, but if you just say one single word and you say the right one, that'll be enough.
Oh, are you asking me unbounded or bounded?
Yep.
Okay. So it's bounded.
Bounded, yep. It's a bounded interval. Can anybody be a little more specific and tell me what kind of bounded interval? Yep.
Half open.
It's half open, yep. So it's a half open, bounded interval. Now what I want to do is write it as an inequality. Right? So we're going to need two of them. Can anybody tell me what my first inequality will be to describe the left-hand side? Yep.
-3 is less than x.
-3 is less than x, or we could also say x is greater than -3. You agree? Yeah, same thing. So x is greater than -3, and what would be my other inequality? Yeah.
X is less than or equal to 5.
X is less than or equal to 5. Perfect. Now the only thing I want to do is combine them into a single inequality. Put the letter in the middle. Smaller number on the left. Bigger number on the right. They should always be pointing to the smaller number. When it's pointing at the -3, it doesn't have the equal to. When we're dealing with it pointing at the x in this inequality, it should have the equal to. So that is what I'm looking for. Any question on that? Just changing an interval to an inequality. Let's try this one. So Rebecca, what kind of interval is this one?
Unbounded.
Yep, it's unbounded. Now, if you tell me it's unbounded, it automatically can't be closed. Because if it's unbounded, that means you have infinity somewhere. And if you have infinity, you will always have a parenthesis. To be closed, you'd have to have brackets on each end. So it's impossible to be unbounded and closed. That's like a contradiction. All right, so this one is unbounded. It's half open. So it's closed on the left, open on the right. Okay, anyone think they could tell me the inequality for this one? Unbounded inequalities are actually simpler. You don't have to write as much. Yeah?
X is more than or equal to -4.
Yeah, and that's it. X is greater than or equal to -4. Some people say, well, don't you have to say x is less than infinity? Well, by default. Yeah, it's automatic. Everything's less than infinity. So you don't have to say that. Just x is greater than or equal to -4. Okay. Any questions on that one? All right. Let's try this one. So Emily, what kind of interval is this one?
Bounded.
Bounded, and in terms of open or closed? Closed. Now, if Emily had said that it was closed, does that automatically mean it's bounded? Yeah, because if it's closed, that means you can reach the value on each end. And if you can reach the value, you don't ever have infinity. So if you say closed, automatically means bounded. Okay, anyone think they could give me this one as a single inequality with x in the middle? Yep, Shai?
-8 is less than or equal to x,
Yep.
which is less than and equal to -3.
Yep, perfect. So if when I pronounce this, I usually start from the middle and pronounce it out. I say x is greater than or equal to -8, and, even though it's not written, you have to say it, and x is less than or equal to -3. Yeah, perfect. Any questions on that one? All right, so now a third way that we can represent a solution, rather than writing it as an interval, okay, rather than writing it as an inequality, is to actually graph it on a number line. So in terms of graphing, you can use the open circle, closed circle. Today we'll stick with either a bracket or a parenthesis. So first thing we need to number the number line. You can number it however you want as long as your numbering is consistent. So just keep it consistent. Like if you go by ones the whole way. All right, so I got to decide what kind of symbol I would put on the 2. Emily, would this be a bracket or parenthesis?
Bracket.
Yep, and now because I could open my bracket and have it facing right or left. Which way should my bracket face? Because that's the direction I'm going to shade. To the right. So we're going to put a bracket on 2 and shade everything right. Any questions on that one? So when you have an unbounded interval, which is what this is, think of it as there's nothing on the other end. It's usually a ray, and it's an arrow, and it just keeps going. That's how unbounded works. If it's unbounded on both ends, then you'd have arrows going in each direction. That's different. But unbounded on one end, starts somewhere, goes one way. Okay, this is going to be very similar. So x is less than 5. So let's go by 5s. How about Michael? What kind of symbol am I going to need on 5, and which way does it open?
Parenthesis to the left.
Yep, parenthesis, opening left. We shade everything left. Again, another unbounded interval. Okay, let's look at this one. So this is a conjunction. So this interval is bounded. So you're not going to have an arrow like we did in the last 2. Okay, so just number your number line. I numbered a little bit more than I needed. That's fine. Okay, let's start with -1. Madison, what kind of symbol do I put on -1?
Bracket.
A bracket opening
To the right.
to the right. So I'm going to put a bracket, and I'm going to indicate that I'm going to be shading to the right, but I'm not going to shade yet because it's not going to be shaded to forever. It's only going to be shaded up to a certain point. How about Megan? What kind of symbol would I need on 3?
A parenthesis.
Yep, and the parenthesis would open to the left. So parenthesis on 3, I'm going to be shading that way. So now shade everything between, but don't go beyond the 2 symbols. All right, so just shade everything like that. So no arrows in this one at all. Okay, any question on that one? So, bounded interval, half open. All right, so now there's 3 different ways I could ask you for an answer. Okay, if you're solving a problem, I might ask you to graph the solution, write it as an inequality, or write it as an interval. It's 3 different ways of doing the same thing. Okay, when we're solving an inequality, it's pretty much exactly the same steps as when you're solving an equation. But there's one thing you have to be careful about. Does anyone remember the one thing you're going to be careful about when you're working with inequalities? If you do something, you have to be careful. Yep. If you divide by a negative, you have to flip the sign, or if you multiply by a negative. Okay, so you can shorten that up if you want to, but basically if you multiply or divide each side of an inequality by a negative, you have to flip the sign. So when you're adding, you don't ever have to worry about flipping. Subtracting, nope. Just multiplying and dividing in just a negative. Other than that, it's the exact same steps as solving an equation. Today we're going to focus on solving linear inequalities. So they're going to look like that. Tomorrow we'll look at solving quadratic inequalities. So that's where factoring is going to be really important. So factoring is a real big part of tomorrow. Not today. Okay, so my inequality says 3 and then in parentheses x minus 1, close parenthesis, plus 2 is less than or equal to 5x plus 6. All right, so Sam, what would be the first thing I would have to do there?
So factor the 3 into the x minus 1.
Hey, can you explain how you do that?
You just 3 times x, 3 times negative 1.
Yeah, so distribute.
Yeah, that's fine.
Yeah, that's why I just asked you to explain it, because I thought you knew what you meant, but just the wrong word. So multiply it out. 3 times x, 3 times negative 1. If you want to add the 2 in your head right now, you can. I'll do it in the next step. So now after you distribute, if there's any like terms, combine those. Negative 1 plus 2 gives me...
That should be negative 3 now.
oh yeah, that would be a problem. So make sure you actually do what I wrote, which is to distribute. And now negative 3 plus 2 gives me a negative 1. Now, if we solve this problem correctly, we can avoid having a negative number in front of x. So what could I do next to avoid having a negative number in front of x? And I'll never have to worry about dividing by a negative. Yeah?
Subtract 3x from both sides.
Yeah, you can subtract 3x from both sides. And the only disadvantage to doing that is now we have the variable on the other side. We don't normally like it on that side. So at the very end, we'll put it on the left. But for now, it's okay. And how about, Carolyn, what would be my next step? Yep, subtract the 6. Now I just subtracted a number, right? That's minus. Should I flip the sign? No, I didn't multiply, didn't divide. Even though I'm going to get a negative answer, it's not just having a negative, it's dividing by a negative. But we're multiplying. And now my last step, I'm going to divide. But what do I divide by?
2.
Positive 2. Don't need to flip anything. So I get negative 7/2 is less than or equal to x. Now, how could I write it with the x on the left side? It would be x, Michael?
Greater than or equal to negative 7/2.
Yeah. So if you want to rewrite something so it's equivalent, look at what it was pointing at before. It has to be pointing at the same thing now. The reason why we usually put it that way is because if you do it this way, the arrow points in the direction you would shade. If this is a problem, you were going to do shading. You'd shade to the right. If you don't put the x on the side we did, then the inequality symbol points in the wrong direction to shade. Even though they're both technically correct. I like the bottom one better. Okay. Any questions on that? All right. So let's look at how we can solve an inequality with a graphing calculator. So first of all, the main reason we would use a calculator is because you have a problem you can't solve easily with algebra. Well, if all we're doing is linear inequalities today, you're always going to be able to solve it with algebra. So technically, there's no problems today you need a calculator for. But there will be tomorrow, right? So I'll show you how to do it. There's two ways you can do it. Okay? And I'll do the same problem twice and show you both ways. First way is to get 0 on one side of the inequality, almost like you're solving a quadratic. Get everything on one side, 0 on the other. And then we're going to calculate a root. But now you have to be careful. The answer to an inequality is never x equals something. X equals is the answer to an equation. So once we have the root, it's usually going to be everything that's bigger than the root, or it could be everything smaller. Depends on the problem. So we're going to look at our graph, and we're going to figure out where it crosses the x-axis, and then look at the question and say, does the question want to know where the graph is above 0, or does it want to know where it's below 0? It'll be one of the two. So we'll go through those steps right now with that example. 4x minus 1 is less than 2. Step 1, get 0 on one side of the inequality. Okay, so how about, Nathaniel, if I want to get 0 on one side here, what do I do?
No, you would just
Subtract 2. So 4x minus 3 is less than 0. So this is going to be a question about where is the graph negative? Where is it less than 0? So keep that in mind. So on the calculator, you're going to type in 4x minus 3, and I'm going to do zoom 6. And what I want to do is now calculate the root. Okay? Or some calculators it says calculate the 0. Okay, the 0 is right there. So my answer is either going to be everything from that red dot to the right, if I want to know where it's greater than 0, or everything from that red dot to the left, if I want to know where it's less than 0. But that red dot is right where it equals 0. Now, I can solve this one quicker in my head just by adding 3 and dividing by 4. So it's going to be at 3/4. But some of them might be a little more complicated. So let's calculate the 0. Pick a value to the left. Pick a value to the right. And do your guess. Okay, I'm going to replace that with this one. So there's your 0. It's at 0.75. So is the answer here everything that's less than 0.75 or everything that's greater? What do you think, Shai?
Less than.
Less than. Because the question is about where is the graph less than 0? If you pick x values that are less than 0.75, like say you pick 0, you're down here. If you pick negative 10, you're way down, okay? If you start picking values more than 0.75, you're going to be up above the axis, and that's not what they want. Any questions on that one? So that's one way to solve an inequality. Get it equal to 0, calculate a root. Here's the second way. The second way, you leave the problem the way it is. You don't move anything around. Leave 4x minus 1 on the left, leave 2 on the right. And you graph both of them. Graph one of them in y1, graph the other one in y2. So I'm going to graph 4x minus 1, and I'm going to graph 2. Now, what I'll do is I'll put colors around them so we can remember which one is which. 4x minus 1 is going to be the blue. And y equals 2, that's going to be the red. So in terms of the color, I'm looking for where the blue one is below the red one. If you want to think of it that way on the screen. Where is the blue one below the red one? Let's graph it. There's the blue line. There's the red line. And now this time I'm not going to calculate a 0. What do you think I'm going to calculate this time? An intersection. So now calculate your intersection. And once you find that, decide, okay, do they want to know where I'm above or where I'm below? Just depends on the problem. This one, they want to know where the blue graph is below. Okay, so let's find the intersection first. We already know from the last problem what it's going to come out to. It comes out to 0.75. Exactly the same thing we just had. So let's take that. Example 5 is what we're doing right now. It's the exact same thing, just using method 2. So now determine if I want the x's above 0.75 or below. Well, if I go above 0.75, okay, like if I pick 3, I'd be right there on the red graph. I would be way up here on the blue graph. After 0.75, the blue graph is above the red. That's not what they wanted. They want the blue graph less than the red. So where does that happen? Any x value before 0.75, less than. Okay, so there's 2 different ways to use the graphing calculator and get the same result. Any questions on that one? Is it calculating roots or calculating intersects? All right, so let's look at this one. So we've already looked at conjunctions. Okay, sometimes we call it like a double inequality. And to solve something like this, the goal is to get x in the middle by itself. So the only thing you have to remember is whatever you do to the middle, you have to do on the left and you have to do on the right. So instead of just doing something on both sides, you'd have to do something on all 3 parts. Okay, divide by 2, divide by 2, divide by 2. Okay, I'm not going to finish solving this one, but that would be the idea. All the same rules apply. If you multiply or divide by a negative, flip the inequalities, plural, because now there's 2 of them, flip them both. But it's exactly the same idea. Okay, so let's look at one we're actually going to try and solve. So this says negative 3 is less than 2x plus 5, all divided by 3, which is less than or equal to 5. So there's 3 numbers you got to get rid of. The 2, the 5, and the 3. Anyone think they know which number we're going to get rid of first in the middle, Sam?
3.
Yep, we're going to get rid of the 3. And how would you undo dividing by 3?
Multiply all 3 things by 3.
Yep. Multiply the left by 3. Multiply the middle by 3. Multiply the right by 3. Well, those 3's cancel out. Now, Sam, did I multiply by a negative number?
No.
Nope, 3's a positive. So I don't have to flip any of my signs. Negative 9 is less than 2x plus 5, which is less than or equal to 15. All right, what would be my next step to get rid of something else in the middle? Yeah, Chase? Yeah, good. Subtract the 5 in the middle, on the left, on the right. So 5's cancel. Negative 9 minus 5 gives me negative 14. It's less than 2x, so we almost have x by itself. Got one more step, which is less than or equal to 10. Okay. And what would be my my last step? How about homework?
You would
So our goal now is to get rid of the 2. So, yeah, not subtract. What did you say? Divide, yeah, because we have 2 times x. So opposite of multiplication, division. Okay, so final answer, negative 7 is less than x, which is less than or equal to 5. And they could ask you to change that to a picture, graph it, or write it as an interval. Any question on that one? So if you get one, I think there's a couple in the homework where not only do they put a variable in the middle, like 2x plus 6, they also throw one on one of the sides like that. If you have a variable and it's not just in the middle, it's in more than one spot, there's 2 ways to solve it. One, you either split it up into 2 problems like this, and you solve each one separate. Okay, so this is a case where you can't get x by itself in the middle, but you can take the part on the left, the part on the right, and solve each one separate. Or, on your calculator, graph what's on the left in y1, graph what's in the middle in y2, graph what's on the right in y3. And what you'd be looking for is where your y2 graph is sandwiched between the y1 and y3. So you could have, just as a simple example, maybe this is y1, this is y3, that's y2. If you're looking for where y2 is sandwiched between the other ones, it would be between here and here. Okay, so if you have x's in multiple spots, you can't get it by itself in the middle. Split it into 2 problems, or use your calculator. Either way. All right, so last thing we're going to look at is, I think one of the last things we looked at yesterday, which was absolute value equations. This is absolute value inequalities. It's pretty much the same idea. In fact, the first step is exactly the same. When you have a problem with absolute values, you want to make sure it's by itself. That's an example of an absolute value inequality that's ready to go. Absolute value is by itself. Here's an example of an absolute value that is not ready to go. You've got something extra on the outside of the bars on the same side. You don't want that. Okay, so in that case, you'd have to divide by 5. If I did something like this, that's still a problem. I would have to subtract 5 from each side. And that would cancel it from the left, and it would move it over to the right. All right, so if we got something like that, we're good. When we split it, the first one is exactly the same as what we wrote yesterday. Copy down the original problem, just erase the bars. So copy down the original, take away the bars. Now, the second one, yesterday we had to do an extra step. We copied down the original, we took out the bars, and what was the one extra thing we had to do? Yep, Emily?
Whatever was on the other side to be opposite.
Yeah, we had to change the number on the other side to its opposite. We're still going to do that today. It's the same as the original. you're going to take away the bars, but if you change a number to a negative on the other side, remember what happens when we deal with negatives with inequalities? You have to flip the sign. All right? So that's the extra thing you have to do. Copy down the original, take away the bars, that part's the same. Make the number on the other side negative, that part's the same. But now the extra step is to flip the sign. And yesterday when we had two problems, we'd have like x equals something, and we always put the word and between them. That was yesterday. Well, today we're going to have a choice. Whether we put the word and between the two answers, or should we put the word or? Well, the way you remember is you look at the original problem. So if I go up to the example I wrote, the original problem has a less than, or less than or equal. Basically, same idea. Anytime you have a less than or a less than or equal, you use and. The original problem had a less than or equal, you use and. If the original problem was a greater than or equal to, you use or. And the way I remember it, less than is an and. So if you remember land, less than begins with L, less than, and. Another way you can remember it too is if you think of greater, pronounce it that way, greater is an or. Okay. So whatever helps. Okay, any question on that? So it's pretty much the same except the end. You got to decide the word and or. So before we even solve this, we should already know what word we're going to use at the end. Is that going to be an and? Or are we going to put the word or in the final answer? Yeah, it's going to be an and. When you have an and, that usually means you're shading between. X is greater than 0 and less than 10. When you have an or, it usually looks like arrows pointing in opposite directions. Okay, so let's solve it. First thing, isolate the absolute value expression. It already is. So we're ready to split it. Kat, can you tell me what my first inequality would be that I would split it into?
X minus 3 is less than.
Yep, that's it. Just copy the original, take out the bars. And, so I don't forget to write that. Alex, how about my second inequality?
Been doing the notes.
Oh, you're catching up on the thing, yeah. So how about Alec, can you tell me my second inequality?
So your second inequality would be x minus 3 is greater than negative 3?
Yep, you did everything. You got rid of the bars, you flipped the sign, made it negative. And now solve each one. So x is less than 6, and x is greater than 0. So basically between 0 and 6, and it's an open interval. Any question on that? I had another one. This would be an or. Does anyone need me to go through that one? It would be the same thing if we went through it, pretty much. Okay, except it's an or instead of an and. Oh. Okay. That's... All right, we'll try one on the calculator. This is an and, something you could solve with algebra. But I'll show you, just in case you don't remember where absolute value is. It's kind of important to know where that is. So let's type it in. This one you could basically use either method 1 or method 2. I'm going to use method 2. So I'm going to go to math number, and I'm going to put the absolute value on y1. I'm going to put 4 on y2. And I'm going to be looking for where the absolute value is less than or equal to 4. So where is the graph in blue below or equal to the graph in red? So let's hit graph and see. Here's my graph in blue. It's a V shape. Here's my graph in red. And I'm looking for where the graph in blue is below the graph in red. That would happen between here and here. If you go outside of those black dots, then the graph in blue goes above. That's not what they wanted. They want to know where it's below. So what would I have to calculate here to find those exact points? Yeah, Emily? Yes, an intersection. You got to do it twice. So blue, red, this is where the guess matters. If you put it closer to the one on the left, it gives me the one on the left. If you do it on the right, it's going to give me the one closer to what's on the right. So blue, red, move it a little closer, that should be close enough. 2.5. So in this case, x is greater than or equal to negative 1.5, less than or equal to 2.5. In between. And if you wrote this as an and, if you write it out, I'm fine with this too. This is just the long way to write it. That's perfectly fine. Any questions on that? All right, so last one. So this is another absolute value. But it's a little weird, right? You can't really isolate the absolute value because it's in the bottom of a fraction.
Well, you could multiply both sides by the absolute value of x minus 2.
So the suggestion was we could multiply both sides by what's in the bottom, which normally if you had something like this, I would say that's how you do it. You want to get rid of what's in the bottom, so just multiply by what's in the bottom, and there's your answer. What's the only thing we have to be careful about, though, when we multiply both sides by an inequality? Yeah, we got to be careful if we multiply by a negative. Now, you might say, well, technically, this is absolute value, right? So it's never going to be negative. Well, we might be able to get away with that on this one, and it might work. But if these bars weren't here, you would not be able to multiply both sides by x minus 2, because we don't know what x is. Could be positive, could be negative, so we wouldn't know if we should be flipping the sign or not. So I'm going to show you something that'll work all of the time, even if the absolute value wasn't here. So we've got a fraction. We're dividing a top by a bottom, and we're getting a number greater than 0. Okay, that's a positive. What would you have to have in the top of your fraction and in the bottom of your fraction? So when you divide them, you always get a positive answer. It's kind of in general. If you want to divide two things and have it come out positive, what could you have in the top and in the bottom? Okay, you could have a negative in the top, and then what would you have to have in the bottom? Another negative. That's one possibility. A negative divided by a negative would come out greater than 0. Or, what's another possibility?
Positive and a positive.
A positive over a positive. Now, out of those two situations, only one of them makes sense here. Does anybody see which one it has to be?
Over positive.
Yeah, it has to be this one. Why can't it be negative over negative?
Because absolute value will always be positive.
Absolute value is always going to be positive. So for this problem, it has to be a positive over a positive. Well, the bottom is already positive all the time. So the only thing we have to check is make sure the top is positive. Because if the top comes out positive, the whole thing is automatically positive. So that's all you have to check. When is the top positive? So you want to make sure x plus 3 is greater than 0. So if you pick any number greater than negative 3, doesn't even matter what you plug into the bottom, it's already positive. Don't even worry about it. But in the top, anything greater than negative 3 will come out positive, which means the whole fraction is positive. Okay, so that one's a little bit different, but actually it's not really too hard if you just think about it the way I just showed you. Any questions on that one? All right. So homework tonight, just on one page, since we only did one section. And there's no real big chunk of problems, it just kind of skips around a little bit. So it's 5 through 7, 10, 11, 14 to 16, and then a bunch of single problems, 25, 26, 29, 34, 35, 42, 43, 49, and 60 to 62. So there's a bunch of other problems in there you can practice, like if you're looking for one to do on the test. I didn't give them to you because it's really more of the same. I try to just give you like roughly 2 examples of each type of thing we went over in class. Because if you can do 2 of them, I'm sure you could do 20. So that's what I do.